Let's look at the solution to the JAMB Chemistry 2022 questions. Question 1 here says, a particle that contains 9 protons, 10 neutrons, and 10 electrons is A. Positively charged, B. Neutral atom of a metal, C. Neutral atom of a non-metal, D. Negatively charged. Now, what's the answer to this question? Let's look at what we have here. For this question, they said the particle contains number of protons equal to 9, number of neutrons equal to 10, and number of electrons, E, it's equal to 10 from the question here. Now they're asking if the particle is positively charged or a positive ion, if it's neutral, or if it's negative. Of course, C says neutral atom of a non-metal. Now, how do we know if this is positively charged, negatively charged, or neutral? How do we know? Now, it's easy. The first thing you want to know is that when an atom is neutral, whether it's a neutral metal or non-metal, if it's neutral, the condition is that the number of protons should be equal to the number of electrons. This is a condition for a neutral atom. Now, in the case where you have more protons, if you have more protons, that's protons greater than electrons here, what will happen is that this will be positively charged because you have more protons, more positively charged particles. Also, if you have more electrons, or if more electrons or the number of electrons is greater than the number of protons, that means you have more negatively charged ions. So the body becomes negatively charged. Now, looking at the particles we have here, considering the protons and electrons, of course, neutrons here have lesser significance when it comes to a body being positively or negatively charged. Looking at what we have here, electrons, number of electrons here is 10, number of protons here is 9. So we can see we have more electrons than protons. So hence, you'll be having a negatively charged body or a negative ion. So the answer to question 1 is D, negative ion. That's the answer. Question number 2, you have this reaction here, right? They said in the endothermic reaction above, that's this one here, more product formation will be favored by A decrease in pressure, B, a decrease in volume, C, this should be an increase in pressure, D, constant volume. Now, considering the equation of reaction we have here, the first thing you want to observe is that the reactant and product formed, they are both gases. All right, you can see this G here means is in a gaseous state, and gases are very much affected or affected significantly by pressure. Right, you want to note that. Now, how are they affected by pressure? An increase in pressure will favor the side with the least number of moles. All right, an increase in pressure will favor the side with the least number of moles. Hence, a decrease in pressure will favor the side with the highest number of moles. In the question, they said more product formation will be favored by. So if we say more product formation, we're looking at going this way here. And going this way here, we can see that this part here has more moles because this one here has 2 moles. Meanwhile, the reactant has just 1 mole. What favors the side with more moles? Will it be an increase in the pressure or a decrease in pressure? As said earlier, we said a decrease in pressure will favor the side with the highest number of moles. And looking at this product side here is the part with the higher number of moles, which is 2 as compared to 1 here. So hence, if you want more product to be formed, we have to favor the product side, and to do that, we have to decrease the pressure. So the answer to this question is A decrease in pressure. It will favor the side with the more number of moles, which is the product side. And that's what you're asking when they said more product formation. So the answer is A. Let's look at question 3. Question 3 says, for a general equation of the nature X of P, right, that's number of moles of P plus Y, number of moles of Q, to give you product R or M first, number of moles of R plus N, number of moles of S. The expression for the equilibrium constant is Now we know that equilibrium constant K is equal to, first things first, it's a ratio of the concentration of the product side, so product raised to n, where n is number of moles, to that of the reactant. So reactants, and also let's call this M. All right. So how do we do this? This is equal to, let's look at the product side. On the product side, we have what there? R and S. So it becomes concentration, square bracket, R. If you look at for R there, what is close to R is what there? M. Number of moles, M. So this into M, and then use this. Next up, you have S there. So it becomes S. The number of moles of S is what there? N. So it becomes N raised to the number of moles all over. Okay, let me do this better. So all over. Let's get for reactants. For reactants, you have P. Number of moles is X. So it becomes P. Number of moles is X. And then you have Q. Number of moles is Y. So it becomes Q. Number of moles is Y. So this is the expression for the equilibrium constant. So let's see which of them has this option. Looking at this, inspecting this, I think that's C. Let's see. C is R to power M, R to power N, S to power N. Yep. P, X. Yep. So that's C. So the correct option there is C. That's your answer. All right. Moving on. Question number 4. The constituents of air necessary in the roasting process are, right? This should be constituents since you're saying are. So the constituents of air necessary in the roasting process are A, oxygen and water, B, argon and carbon dioxide, C, carbon dioxide and water, D, oxygen and carbon dioxide. Now for this question, that's question number 4, you need to know that first things first, the constituent of air, for air, the constituent includes oxygen, carbon dioxide, nitrogen, that's N2, and let's say noble gases. All right, so I'll call this noble gases. All right, you have this. Now for this, when it comes to the roasting process to take place, the presence of oxygen, the presence of water, that's H2O, and then the presence of carbon dioxide, which is CO2 here, they are important. Now, looking at this here, comparing with what we have here, they said for roasting process to take place, I need these three. I need carbon dioxide, that's CO2. I need oxygen, O2. I also need water. So which of these matches the correct options here? Looking at this here, you'll be tempted to pick C because you have carbon dioxide and water. But water is not primarily a constituent of air. So instead, we'll pick what there? Carbon dioxide and what there? Oxygen, which is what there? D. So the correct option there is D. All right? Carbon dioxide and O2, that's oxygen. So that's the correct answer. All right, next up, question number 5. Question 5 says the diagram above, that's this one here. Y is A, fuse CaO, that's calcium oxide, B, H2O water, C, NaOH, sodium hydroxide, D, concentrated H2SO4, tetraoxosulfate 6 acid. So what's the correct answer? Now, the first thing you want to note is that this diagram is not clear enough, but from what we have here, what they are trying to illustrate here is the preparation of sulfur dioxide. That's it. All right, sulfur dioxide. And in the preparation of sulfur dioxide, by the action of dilute acids on sulfates, and bisulfates, the concentration H2SO4 helps to release the sulfur dioxide, that's SO2, from the mixture. So from this here, the setup requires the production of sulfur dioxide or sulfur dioxide. Hence, the right answer should be the concentration of H2SO4 because this is what is needed in the release of SO2. So that's the answer to this. Question number 6 says, this one here, X being a gaseous element, plus 3 moles of Y, still being gaseous, gives you 2 moles of Z. And they give you H here. And they tell you that H is positive. All right. If H is positive, by the way, H actually means the enthalpy. They are telling you that the enthalpy is positive. And they are asking if the reaction above takes place at room temperature, the change in G will be A, negative, B, 0, C, positive, D, indeterminate. The first thing we want to note is the meaning of change in G. All right. Now, what is the meaning of change in G? Change in G simply means Gibbs free energy. All right. So change in G is simply Gibbs free energy. Let me write this down. Gibbs free energy. And the formula for this is that change in G it's equal to change in H minus T change in S. All right. Where change in H here is simply change in enthalpy. All right. Change in enthalpy. Change in S, this one here, is simply change in entropy. So change in H is enthalpy, S is entropy. Now, for us to get the value of change in G, these values, which is change in enthalpy and the value of change in entropy, must be given. Of course, likewise, T here, which is temperature must also be given. Now, temperature, of course, this way must also be given. Now, looking at the question here, you can see that the values were not given here. So the answer becomes indeterminate. Indeterminate means that we cannot get the values. Why? Because the value of change in G, temperature, and entropy, change in entropy here, was not given in the question. So it becomes indeterminate. So assuming these values were given, we could have calculated this. So since they were not given, it becomes indeterminate. All right. Question number 7. Question 7 here says, if 100 centimeter cube of oxygen passes through a porous plug in 50 seconds, the time taken for the same volume of hydrogen to pass through the same porous plug is, they give you the atomic mass of oxygen as 16 and then that of hydrogen as 1. So how do we solve question number 7? To solve question number 7, we'll use Graham's law of diffusion. All right. So for number 7, what we use here is Graham's law of diffusion. Now, how do we use this law? The first thing you want to notice that from Graham's law of diffusion, we have that rate, R-A-T-E, rate is directly proportional to the inverse of square root of molar mass. So you have this. Or perhaps you can say that rate is inversely proportional, all right, to the square root of molar mass. But you want to note that when we say rate, rate is simply the inverse of time. That's the meaning of rate, all right? When we say rate, we mean 1 over time. So if you replace this, it means that rate here becomes 1 over time. Let's use T. 1 over time, that's T, is directly proportional to or inversely proportional to 1 all over square root of molar mass. This. With this here, with mathematical knowledge, of course, it means that time here should be directly proportional to what there? This one here. That means time is directly proportional to what there? The square root of molar mass. You have this. So basically, if you want to take this man off here, becomes time is equal to the square root of molar mass. Now, the reason why we did this way, by saying time is directly proportional to the square root of molar mass, is because they have the same numerator. So mathematically, that is correct. Now, if this is true, looking at what we have here, question number 7, they mentioned oxygen and hydrogen. So if they mention oxygen and hydrogen, let's take the ratio of their time. So we can say the time it takes for hydrogen, the ratio of the time for hydrogen all over the time for oxygen would be equal to, for hydrogen, we said it's equal to change, or it's equal to For hydrogen, we said is equal to the square root of molar mass. So it becomes square root of the molar mass m of hydrogen all over the square root of the molar mass of what there? Oxygen. In the question here, what you asked to find? We asked to find the time taken for the same volume of hydrogen. That's T of hydrogen. That's what you're asked to find. And if that's true, let's get T of hydrogen. To get T of hydrogen, simply move T of oxygen, the time for oxygen upwards here. That's mathematically correct. So we can say the time for hydrogen is equal to, this goes to numerator, it becomes the time for oxygen there, multiplied by the square root of the molar mass of hydrogen all over the square root of the molar mass of oxygen. If you're very good with mathematics, this will be equal to the time for oxygen. Whenever you have two things here like this, dividing themselves and in a square root sign, you can take them in the same square root sign. What I mean is that if I have square root of A all over square root of B, this is the same thing as saying putting them under one square root sign and saying A over B. That's correct. So this becomes this into the square root of the molar mass of hydrogen all over the molar mass of oxygen. That's correct. Now let's impute values. 7, the time for oxygen, they said if 10 cm cube, all right? Yep. Now, since they mentioned the same volume, we will not bother about the volume. What we are concerned here now is the time for oxygen, which is what there? 50 seconds. You can see it here in 50 seconds. So TO is 50 seconds. Let's get that. T naught or T for oxygen is equal to 50 in seconds. What is the mass or the molar mass of hydrogen? In this case here, don't forget that hydrogen is actually H2. All right. So H2 becomes atomic mass of hydrogen is 1 times 2 because I'm having H2. This is 1 mole of hydrogen. So H2 becomes atomic mass of hydrogen 1 times the number of atoms here 2, and that's equal to 2. So the molar mass of H2 or hydrogen atom is 2. For oxygen, we know that oxygen is also diatomic, so that becomes O2. Now for O2, let's get M of O. That simply means for oxygen, coming back to this, so this is how we got H as 1. The atomic mass 1 times number of atoms 2. For oxygen, atomic mass is 16, so O is 16. That's 16 times, again, number of atoms here 2. 16 times 2, and that's equal to what there? 32. So MO is 32, MH is 2. Let's put the values here. That means TH is equal to T naught, which is 50, into the square root of the mentioned MH. MH is 2 all over M naught. M naught is 32. That's 32. Of course, 2 here, 1, 2 here, 2 times 16. That's equal to 50 square root of 1 all over 16. We have this. From here, TH is equal to 50. The square root of, let's take numerator there. Square root of 1 is, so this times, square root of 1 is 1 all over. Square root of 16 is what there? 4. So from here, we have 50 times 1, which is 50, divided by 4. 50 over 4 gives you 12.5 time in seconds. So I'm having 12.5 seconds. Let's see what option that is. 12.5 seconds. Option number B. Option B here. 12.5 seconds. So we have this. All right. Question number 8. Question 8 says, in which of the following reactions will an increase in pressure shift the equilibrium position to the left? All right. Now, to answer this question, let's recall what we said earlier. We said earlier that an increase in pressure will tend to shift the equilibrium to the side with the least number of moles or volume, and vice versa. Now, in the question they said, in which of the following reaction will an increase in pressure shift the equilibrium position to the left? Now, if the equilibrium position should shift to the left, it means we should have the lesser number of moles at the left. So what they're asking you for here is that In which of these following reactions do you have the lesser number of moles on the left? That's the question. Look at A. In option A, you have 2 moles. Looking at hydrogen here, you have 2 moles of hydrogen on the left. On the right hand side, you have 1 for this. So you have 1 here and then 1 here, which is in total 2 moles here and 2 moles. You have equal number of moles, and that's not the answer. We're looking for the one that has a lesser number on the left. Look at option B. You have 2 moles here and then 1 mole here. In total, I have 3 moles here. On the right, I have what there? 2 moles. Nope. The left is still greater than the right. We're looking for a case where the left will be lesser than the right. Looking at number 3 or D there, come to D. For D, looking at the left hand side, we have 3 moles of hydrogen and 1 mole of nitrogen. And then on the product part, we have 2 moles. If I look at the combined number, we have 4 moles on the left and 2 moles. The left is still higher. But if I come to C here, observe that in C, I have 1 mole of N2O4. On the right hand side, I have what there? 2 moles of NO2. You can see that I now have the lesser number of moles on the left hand side. So that becomes the correct answer. All right. So the answer here is C. That's my answer. All right. Question number 9. Question 9 says chlorine consisting of 2 isotopes of mass number 35 and 37 has an atomic mass of 35.5. The relative abundance of the isotope of mass number 37 is A 20, B 25, C 50, D 75. So how do we solve this question? Now, to solve this question, you need to know something. Let's call this question number 9. For question number 9 here, talking about relative abundance, for a particular element, note that the sum of the different isotopes, so it has to be an isotopic element. That means an element with an isotope. The sum of the different isotopes multiplied by their relative abundance, all right? Ra means relative abundance, should be equal to the relative atomic mass of the element. So RAM is relative atomic mass. Ra is relative abundance. In this particular question, question number 9, they mentioned the element chlorine. And they said chlorine, Cl. We know that chlorine is atomic number what there? 17. They said it has 2 different isotopes, 35 and 37. So I'll put this chlorine 35 and Cl, chlorine 37. I have this. Now for this, let the relative abundance of chlorine 35 17, this let it be equal to X. Let the relative abundance of chlorine 17 37 be equal to, let it be equal to Y. You have this. Now here's something to note about isotopes with relative abundance. You should have that the relative abundance of the first isotope plus that of the second isotope should be equal to what there? 1. You have this. All right, should be equal to 1. Now with this, we can find the value of Y. All right, so if I'm having an element with different isotopes, I should note that the sum of their relative abundance, right, should be equal to what there? 1. Please take note. To get the value of Y here, I'll move X over here. So Y will be equal to what there? 1 minus X. So we can have Y here, which is equal to what there? 1 minus X. It's the same thing. Coming back to the question here, you can see that it said the sum of the different isotopes multiplied by their relative abundance should be equal to what there? The relative atomic mass. So from here, let's start with 35. It means that 35, so 35 times each relative abundance, X, this plus, next up is 37, so isotope 37 multiplied by each relative abundance. Let me use the square bracket, 1 minus X. Okay, let me do it properly. In science, you use square bracket first. Square bracket 37 multiplied by y, which is 1 minus x. This should be equal to the relative atomic mass, which is given here as 35.5. So an atomic mass of here, 35.5. So this is simply 35.5. So let's get this clear. To solve this question, the first thing you have to do is to get their isotopes. We're given isotope 35. Question 11 here says, calculate the number of moles of HCl, hydrochloric acid, present in 20 centimeter cube of a 0.75 molar solution of the acid. A 0.015 moles, B 0.038 moles, C 3.800 moles, D 1.5 moles. Now, how do you solve this question? Looking at this question here, you can see that you're given 0.75 m, right? M means molar, and that's for molarity. So question number 11, you're given the molarity as equal to 0.75 molar. Again, you are given volume here, present in 20 centimeter cube. You are given volume, so volume V as equal to 20 cm cube. All right. So you're asked to find the number of moles, right? Calculate the number of moles. All right. So how do you solve this question? The first thing is that I want to record that molarity, all right? Molarity is simply the ratio of the number of moles, all over volume, right? All right, all over volume. So you have this. Now, you want to also notice that molarity is measured in mole per dm cube. Number of moles is in mole or mol. All over, the volume is measured in decimeter cube, not centimeter cube. In essence, from this, all I have to do is that if I want to get the number of moles, of course, this could be all over 1. So if I multiply this by 1, I have that number of moles times 1 gives you number of moles is equal to the product of molarity and volume. It becomes molarity times volume. So we have this. All right, so this is now equal to, again, I want to note that we said volume should be in dm cube, not cm cube. So if I have volume in cm cube here, my task would be convert it to dm cube. And to convert from cm cube to dm cube, you will divide by 1000. So that becomes 20 divided by 1000. And if you do this division there, 20 over 1000, you have your answer as 0.02 dm cube. So you've now converted from cm cube to dm cube. And if you want to know why we're dividing by dm by 1000, let me show you how that is done. Record that we have 10 centimeters making 1 decimeter. If I cube both sides, it becomes 10 cm, this one here, cube. This would be equal to 1 dm, this also cube. This cube affects 10. 10 cube becomes 1000. Then in this one here, cm is also cube. 1000 cm cube would give you 1 cube. 1 cube is 1 times 1 times 1, which is 1. Then dm takes the cube, so 1 dm cube. So basically, this is the relationship between cm cube and dm cube. In the question there, we're given 20 centimeter cube. So we come under the centimeter cube, we write 20 centimeter cube is equal to, let's call the value x in dm cube. Here's how to do simple conversions. If I cross multiply, x times 1000 gives you 1000x is equal to 20 times 1 gives you 20. To get x, I'll divide this by 1000. Divide this by 1000. So this cancels this. So x is equal to 20 divided by 1000, 0.02. So you can now see how we got our answer as 0.02 dm cube. So that's how you do your conversion. All right, so number of moles is equal to the molarity, 0.75 molar. All right, so that becomes 0.75 molar. Molar, again, as we said, this M is called molar, and molar is the same as mole per dm cube. It's the same thing. Times the number of times the volume, 0.02, and that's equal to, so you multiply this 0.75 times 0.02, 0.75 times 0.02, you have your answer as 0.015. You ask to find number of moles, so it becomes this moles. So let's see which option has 0.015 moles. Let's see. That's option A there. Option A, 0.015 moles. That's the correct answer. All right. Number 12. Number 12 says the salt formed from a weak acid and a strong base hydrolyzes in water to form a saturated solution, B, an acidic solution, C, a buffer solution, D, an alkaline solution. The answer to this question is D, right? It hydrolyzes in water to form an alkaline solution. All right, so take note. That's the answer to this question. Next up, question number 13 says an isomer of C5H12 is, right? Now I want to talk about C5. C5H12 is simply pentane. A, 2-methylbutane, B, butane, C, 2-methylbutane, D, 2-methylpropane. Now you have C5 there. When you have C5, it means you have 5 carbon atoms there. The easiest way to get this is to add up the number of carbons. Now, what do I mean? When we say 2-ethyl, in this case, eth is 2 carbons, all right? 2 carbons forms eth. When you have but is 4 carbon. So 2 plus 4 gives you 6 carbon. Remember that we have 5 carbon here. So that means this cannot be the answer. All right, I'm giving you a short way of doing this. When you have, this is just butane. But is 4. When you have 4 carbon, it's called a but, which cannot be. If you come to C, we have methyl. Methyl is when you have 1 carbon atom. Butane is when you have 4 carbon atoms. So it becomes C4. Right? So 1 plus 4 gives you 5, which is exactly the same thing as 5 we have here. This 5 we have here. This one here. Let's see the next one there. 2-methyl. Met is 1 carbon. Propane. Prop is 3 carbon. 3 plus 1 gives you 4. So the only one that matches 5 here is C. So I'll take 2-methylbutane. All right, this is like a quick way of doing this. Now, in a case where you now have 2 compounds having 5 and 5, you may now want to draw the structure. But in this case, I don't really have to draw structure, knowing fully well that this is the only one that has 5 carbon. So this has to be the answer. All right. If you're okay, you can still draw the structure and then see that it will be the same. All right. Okay. Number 14. A mixture of sugar and sulfur can best be separated by dissolution in water, followed by A, evaporation and A, filtration and evaporation, B, decantation and filtration, C, centrifugation and evaporation, D, decantation and evaporation. So what's the answer to this question? For this question here, to answer this question, you want to know that you have sugar and sulfur being dissolved in water. And you also want to know that sugar would completely dissolve in water, all right, giving you a sugar solution, leaving sulfur. So what to do is very simple. With that solution, with that mixture having sugar, sulfur, and water, you pass it through a filter paper. When you pour the mixture into a filter paper, you now observe that sulfur would still be left on the filter paper. Meanwhile, the sugar and water forming your sugar solution will pass through the filter paper. So you'll be having sulfur on the filter paper, and then you'll be having sugar solution after the filtration process. Now, the next thing to do is that you pick up your sugar solution and you heat it. That's evaporation. Now, when you heat this, you observe that the water molecules will evaporate, leaving you with just sugar. So the process there would be filtration and then evaporation. The answer is A. Question 15. According to Charles' law, the volume of a gas becomes zero at, right? What's the volume of a gas at zero at what particular temperature? Now, here's what we know. We know that from number 15, we know that 0 degrees Celsius is equal to 273 K. Now, when they said the temperature becomes 0, the volume of a gas becomes 0 at, all we have to do is let's make K to be 0. And to make K to be 0, we have to subtract 273 here and also subtract 273 here. All right. Now, if you do this, 0 minus 273 gives you, that's this 0 minus 273 gives you minus 273, of course, degrees Celsius is equal to 273 minus 273. That becomes 0 Kelvin. So the answer there would be minus 273 degrees Celsius. So that's the answer there. Minus 273 degrees Celsius. Number 16, mild oxidation of propan-1-ol will yield A. Propanone, B. Propanal, C. Propanoic acid, D. Propane. Now, here's a question under organic chemistry, all right? The oxidation of an alcohol, right? Propan-1-ol is an alcohol. Now, you want to know that this propan-1-ol is actually a primary alcohol, right? It's a primary alcohol. And when it comes to primary alcohol, note that the oxidation of primary alcohol will yield alkanals, right? So primary alcohol, primary alcohol, mild oxidation, so it becomes plus, this mild oxidation will produce an alkanal, all right? So you have an alkanal. An alkanal is also called an aldehyde. It's the same thing. So you can check out our playlist on organic chemistry to learn more. Now, the alkanal version of this would be then take this one here, anal. So it becomes propanal. So in essence, the correct option there is B, propanal. So take note that the mild oxidation, emphasis on mild, right? The mild oxidation of propan-1-ol will yield propanal. That's the correct answer, right? Number 17, a solid that absorbs water from the atmosphere and forms an aqueous solution is A. Hydrophilic, B. Efflorescent, C. Deliquescent, D. Hygroscopic. Right. So what's the answer to this question? Now note that the process by which a substance absorbs moisture from the atmosphere until it dissolves in the absorbed water and forms a solution is called deliquescent. All right. So the correct option here is C, deliquescent. That's your answer. All right. Question number 18. The process that occurs when two equivalent forms of a compound are in equilibrium is A. Isotopy, B. Resonance, C. Isomerism, D. Reforming. So what's the answer to this question? Now, note that when it comes to resonance, resonance involves two forms of a compound, right? It involves two forms of a compound. When it comes to isomerism, that's the C1 here, isomerism involves two or more forms of an element. When it comes to reforming, note that reforming involves the arrangement of molecules, all right? But for resonance, this deals with two forms of a molecule where the chemical connectivity is the same, but the electrons are distributed differently around the structure. So the answer there is B, resonance. That's your answer. Question 19 says, an organic compound commonly used as a disinfectant is dash. A, toluene, B, glycerol, C, styrene, D, phenol. Now note that toluene, let's start with the first one there, toluene. Toluene is used basically as a disinfectant, okay? Glycerol is usually used as a sweetener, right? For styrene, you want to note that styrene is used in plastic products packaging. For phenol, phenol is used for sore throat, all right? So for this, the answer is toluene, all right? So the answer to this question here is A, toluene, all right? Toluene is the organic compound that is commonly used as a disinfectant. So that's it. Question number 20 here says, temporary hard water is formed when rainwater containing dissolved carbon dioxide flows over deposit of, you have your options here, all right? A, calcium trioxocarbonate 4, B, sodium trioxocarbonate 4, C, sodium tetraoxosulfate 6, D, calcium tetraoxosulfate 6. What is the answer to this question? Now for 20, you want to note that permanent hardness in water, all right, permanent hardness is caused by the presence of magnesium and calcium sulfate, all right, calcium sulfate. Meanwhile, temporal hardness of water is caused by the presence of magnesium and calcium carbonate, right? So from this, we can see that temporal hardness of water or temporary hardness of water is caused by magnesium and calcium hydrogen carbonate, and it is formed when rainwater containing dissolved calcium 2 oxide flows over it. So for this question there, the correct answer is A, right? So you have your answer as A. That's calcium and the carbonate, or triisocarbonates 4. So that's A. Let's look at question 21. 21 says, butter is an example of emulsion in which A, solid is dispersed in a liquid medium, B, gas is dispersed in a solid medium, C, liquid is dispersed in a solid medium, D, liquid is dispersed in a gas medium. For this question here, you want to know that there's something called a colloid, all right? A colloid is simply a heterogeneous system in which a substance is dispersed in another substance known as the dispersion medium. Butter, cheese, margarines are examples of colloids that are dispersed from liquid medium to solid medium. So for this question here, the correct answer is option C, from liquid, or liquid is dispersed in a solid medium. 22, a given mass of gas occupies 2 dm cube at 300 Kelvin. At what temperature will its volume be doubled, keeping the temperature constant? Now, to solve this question here, we need to use, they said, keeping the pressure constant. Now, for constant pressure, what we use is Charles' law. So let's recall something. This is 22. Let's recall from Charles' law, for constant pressure, we have that V1 all over T1 is equal to V2 all over T2. Now, continuing from this, from here they said a given mass of gas occupies 2 dm cube, that's your V1, at 300 K, that's the value of T1. So we have 2 all over 300 is equal to, now you're asked, at what temperature will its volume be doubled? Now, if I'm to double volume, double simply means to multiply the volume by 2. So if V2 is being doubled, it's simply 2 times V1, and that's simply 2 times, the value of V1 is 2, and that gives you what there? 4. So this becomes 4 all over T2 is unknown, all right? So V2, they said they double the initial volume, that becomes 4. From here, if I cross multiply, this times this, 2 times T2 gives you 2T2 is equal to 4 times 300, that gives you 1200. I have this. To get T2, divide here by 2, divide here by 2, this cancels this. We'll have that T2 is equal to 1200 over 2 gives you 600. Of course, temperature was in Kelvin, so my answer here is simply 600 Kelvin. We'll check which option that is. For 22, that's option D, 600 Kelvin. Question 23, the reddish brown rust on iron roofing sheet consists of. Now, to answer this question number 23, all right, so for this, you want to note that iron 3 ion, that's Fe3 plus, will combine with oxygen ion, that's 2 minus. If this combine, you'll be having this. So this 2 comes down here, it gives you Fe2. Then you have oxygen. The 3 comes down here, you're having 3. So you have this, all right? Now, when this combines with water, So you'll be having something that looks like this. Fe2O3, this plus water, H2O. Combine this, you would be having something that looks like this. Fe2O3 dot H2O. So you have this. All right, so you have this. Right, so you'll be having something that looks like this. So if we compare this, right, to the options there, right, the correct option is C here. This is more of this having 3 molecules of water, which is still the same thing. The answer there is C. That's the answer. 24, incomplete oxidation of ethanol yields, all right, if I have an alkanol, right, that's or an alcohol, if it undergoes mild or incomplete oxidation, you have an alkanal. So basically you have an alkanol. This is under organic chemistry, undergoing mild oxidation. This is how I represent that. Mild oxidation, it gives you an alkanal. So you have this. Now, if we're given ethanol there, ethanol is C2H5OH undergoing mild oxidation. That's this. What you have there is an alkanal CH3CHO. This is an ethanol. This is an ethanal, right? This is an ethanal. Meanwhile, this is an ethanol, right? This is under organic chemistry. Make sure you check my playlist on organic chemistry to learn more about this. So let's see which option is this ethanol, CH3CHO, which is option D here. This is the correct answer. Question 25. Which of the following is the least soluble in water? That's 25, okay? Which of these is the least soluble in water? Now you have this one here. A there, aluminum hydroxide. B, calcium hydroxide. C, sodium hydroxide. D, potassium hydroxide. The correct answer for this question is actually aluminum hydroxide. Of all the options given here, the least soluble in water will be aluminum hydroxide, of course, followed by calcium hydroxide, and then this one's here. All right, so the answer is this. So you could note this question. 26 says the acid anhydride that will produce weak acid in water is, so which of these acid anhydride will produce weak acid in water? A, sulfur 6 oxide. B, nitrogen dioxide. C, sulfur dioxide. D, carbon dioxide. So which of these is the answer? Now for this question here, you want to take note that when we talk about strong and weak acid, you want to take note that this H2CO3, which is simply hydrogen trioxocarbonate 4, is an example of a weak acid. Meanwhile, acids such as H2SO4 and HNO3, these ones are strong acids. All right. Meanwhile, this is a weak acid. You have this. Now, to get this one here, that's hydrogen trioxocarbonate 4, you will have that carbon dioxide, CO2, would combine with water, H2O, to give you H2CO3. All right. So this is a weak acid formed by the combination of carbon dioxide in water. So the correct answer there, when you talk about weak acid, the answer there is carbon dioxide, which is this one here. This. So the correct option is D. All right. So next up, question number 27. The product of the decay of phosphorus 32 as a beta emitter is, all right. First things first, when they say phosphorus 32, what this means is that 32 is the mass number. And we know that phosphorus is actually P. All right. So it becomes, this is 27. So 27, you have phosphorus P. When they say 32, it means that is the mass number of this. And we know that from the table of elements, phosphorus is atomic number 15 from the table of elements. So you have this. Now, they said it's undergoing a beta decay, or it's a beta emitter. If it is emitting beta, would subtract a beta. Now, for beta particle, we know that a beta particle is simply an electron. That's electron there, having a mass number of 0 and atomic number -1. So let's subtract this. If you look at this, we'll have that 32 minus 0 gives you 32. 15 minus minus 1. You're having 15 minus minus 1. Minus minus gives you plus. 15 plus 1 gives you what there? 16. Recall that this shows you the atomic number. So we'll ask ourselves, which element has atomic number 16? And the answer there is sulfur. So it becomes S here. So this becomes the symbol there, 3216S. So let's see what we have there. That is option C. That's the correct answer. All right. Next up, 28. 28, you have carbon hydroxide combining with 2 moles of ammonium chloride would give you calcium chloride plus hydrogen peroxide plus what? Now, if you know the complete equation of this reaction, what you'll be having there is simply calcium hydroxide, that's CaOH2. This would combine with ammonium chloride, NH4Cl, of course 2 here, to give you calcium chloride, CaCl2, plus you also have water, 2H2O, plus the last product you have here is 2 moles of ammonia, that's NH3. All right, so that's what you have next, 2 moles of ammonia. Let's see what we have here. From the option, you have B, ammonia. So I'm taking B. This is the correct answer to the question. Next up, question number 29. The enzyme used in the hydrolysis of starch to dextrin and maltose is A. Amylase, B. Diastase, B. Diastatase, C. Invertase, D. Zymase. The correct answer to this question is amylase. So please take note that amylase is the enzyme that is used in the hydrolysis of starch to dextrin and maltose. Take note of this. Next up, question 30. Question 30 says the general formula of the alkanones is. Now for the alkanones, you want to note that the alkanones are also called the ketones, right? They also called the ketones. And for the ketones, you have your formula as C, double bonded to oxygen, right hand R, left hand R. Or you could say R prime if you want. If I write this in full, this becomes R, this one here. Then you have this one here, C, then you have O, so O, then you have R, so you have R. That becomes RCOR, or depends. Some authors want to say you have one R and the second R. So you might see something like R2CO. Any of them is the same thing, right? So let's see which of them here has this option. Coming back to the options here, between option A, B, C, and D, we can clearly see that option B is the correct answer, R2CO. But you want to take note that the most correct form of this is actually R, single bond to C, double bonded to oxygen, single bonded to R prime. This is the most correct option, which can still be written as RCOR prime. This is the most correct form, okay? But writing in this form as the option requires is still not so much of a problem, right? Question 31 says, water for town supply is chlorinated. This should be chlorinated. Is chlorinated to make it free from A, bad color, B, bacteria, C, temporary hardness, D, permanent hardness. Now for this question, you want to note that chlorine helps to keep water free from germs and bacteria. The correct option here is B, free from bacteria. Question 32. In the laboratory preparation of ethyl ethanoate, the water present in the mixture is removed using a solution of A, anhydrous calcium tetrachloride, B, concentrated sodium tetraoxocarbonate, C, dilute sodium hydroxide, D, concentrated hydrogen tetraoxosulfate 6. I think this should be H2SO4. Yep. So for this question here, you want to note that in the preparation of ethyl ethanoate, that concentrated H2SO4, that is hydrogen tetraoxosulfate 6, is used in the preparation of ethyl ethanoate to remove the water present since it serves as a dehydrating agent. So it serves as a dehydrating agent in this process. So the answer here is concentrated hydrogen tetraoxosulfate 6. Question number 33. The pollutants that may include the condensation of water vapor in the atmosphere is A. Dust, B. Soot, C. Oxides of nitrogen, D. Chlorofluorocarbons. So what's the answer to this question? Now note that the answer here is soot, all right? Soot is a mass of impure carbon particles resulting from the incomplete combustion of hydrocarbons. It is a pollutant that induces the condensation of water vapor in the atmosphere. So the correct option here is B, soot. Question 34. The tincture of iodine means iodine dissolves in A. Ethanol, B. Bromine chloride, C. Chlorine water, D. Water. Now note that the tincture of iodine is also called the weak iodine solution. All right. Tincture solutions are characterized by the presence of alcohol. So if you look at the option here, the alcohol here is actually a ethanol. So that becomes the answer to this question. Next up, question number 35. 35 says chlorine gas turns a damp starch iodine paper A. Pink, B. Colorless, C. Red, D. Dark blue. All right. Now you want to note that the reaction of iodine mixed with starch and later in the action of chlorine turns it blue-black. Right? It's blue-black. So for this, looking at what we have there, the answer becomes dark blue. All right? Since we should have a blue-black, and that's something that's what there, dark blue. So the correct option here is D, dark blue. Question 36. Hardness of water is caused by the presence of the ions of A. Calcium and magnesium, B. Calcium and sodium, C. Magnesium and silver, D. Sodium and potassium. All right. Now note that for this question, note that temporary hardness of water is caused by calcium and magnesium trioxocarbonate 4. All right. So calcium and magnesium trioxocarbonate 4 causes temporary hardness of water. Meanwhile, permanent hardness of water is caused by calcium and magnesium tetraoxosulfate 6. So if you look at the two of them there, two things are involved there, calcium and magnesium. So in essence, the correct answer there is A, calcium and magnesium. Question 38. Which of the following is a base? A. Carbon dioxide, B. Calcium oxide, C. Hydrogen tetraoxophosphate, D. Ethanoic acid. Which of the following is a base? Now you want to note that oxides of metals are basic in nature, while oxides of non-metals are acidic in nature. Oxides of metal are generally basic in nature. All right. So also note that hydroxides of metals are basic. So we just said that oxides of bases. So we just said that oxides of metals are basic in nature. So looking at the options here, of course, D is actually an acid, ethanoic acid. So it cannot be D. Then looking at the other ones here, we have oxides of certain compound. For A, there we have oxides of carbon. Carbon here is not an acid. Carbon here is not a metal. All right, we said is the oxides of metals that are base. Carbon here is not a metal. Also, hydrogen here is also not a metal. So the metal we have here is calcium. And we just said the oxides of metals are actually what they're basic in nature, or they are bases. So what that means is that the correct option here for this question, it's actually B, right? B, calcium oxide. So we have this. All right, 38. The solubility in moles per dm cube of 20.2 gram of potassium trioxynitrate 5 dissolved in 100 gram of water at room temperature is, so you have these your options. So how do you solve this question? Now to solve this question for question 38, you want to note that the formula for solubility is equal to mass of solute, mass of solute all over mass of solvent, all over mass of solvent, right? So mass of solute all over solvent. Looking at this here, you can see they said the solubility in moles per dm cube of 20 gram of potassium trioxynitrate 5 dissolved in 100 gram of water. Water is the solvent, that's the liquid. Meanwhile, potassium trioxynitrate 5, this one here, becomes your solute. So I'm having mass of solute 20.2 all over mass of solvent 100. That becomes 20.2 all over 100. And if you do this, you have your answer 0.202. That's approximately 0.2. That's the answer there. All right, so let's see which option has that 0.2. That is option B. Yep, that's option B. So in essence, the answer to this question is option B, 0.20. That's it. 39. Catalytic hydrogenation of benzene produces A. Oil, B. Cyclohexone, C. Cyclohexane, D. Margarine. All right. For this question here, the correct answer here is simple. You're looking at catalytic hydrogenation of benzene. So that becomes benzene. This is calculated structure of benzene. So you have benzene having 1, 2, 3. This is undergoing catalytic hydrogenation. So you have H here, perhaps you have H2 here, right? 3 of it. And when you do this, what happens here is that for this one here, you have that these double bonds here, 1, 2, and 3 will be broken. So you now be having it as this. So you no longer have double bonds there. You now have just single bonds. And what you have here is a cyclohexane, right? So let's see which option has this as cyclohexane. That is option C, cyclohexane. That is the answer to this question. Finally, question 40. Question 40 says, in the diagram below, X is, so this is X, this diagram here. Now the diagram is not clear, but I'm going to explain this diagram for you. Now you want to note that this setup here is used, or the setup here represents the production of sulfur dioxide, and the cylinder marked X, this one here, is sulfur oxide, right? That's sulfur dioxide or sulfur oxide. So basically, this is setup is used in the production of sulfur dioxide, also known as sulfur oxide. And the correct option here is what? B. That's the correct answer there. Let's look at the final set of questions in the JAMB Physics 2022 examination. Question number 41 says, calculate the upthrust on an object of volume 50 cm cube, which is immersed in liquid of density 10 to the power 3 kilogram per meter cube. Take G as equal to 10 meter per second squared. Now, how do we solve this question? The first thing we want to do is to identify the parameter in question. The question here said we should calculate the upthrust on an object. You want to note that upthrust is simply a force that acts on an object when it is being immersed. By immersed, we mean put inside a liquid. So here's the thing. If I have a bucket of water, something like this, or a bowl of water like this, of course, containing water, this, and I have a ball here. If I put this ball inside the water, so bring this down, right? If I immerse this ball in water like this here, of course, the ball will be going downward. There is a force that will tend to act upward, of course, according to Newton's third law of motion. To every action, there's an equal and opposite reaction. So the force that acts opposite of this ball that is being immersed in this water is called the upthrust. All right. There are other forces that could act, such as the viscosity of the fluid. But for now, let's focus on upthrust. Now, with this being said, the key thing you want to note here is that upthrust, as we said, is a force that acts in the opposite direction, that's upwards, of an object being immersed inside a liquid. So the idea is this, that upthrust is actually equal to or is a force. So force here. That's what you want to note. And of course, it's measured in Newton. Now with this, let's recall something. Let's call upthrust. Let's call this U. So U, upthrust, is equal to, for force, the unit for force can be given by mass times gravity. We're using gravity here because the object is being immersed vertically downward. So when an object is being immersed vertically downward, we don't readily say F equal to ma. No, we replace A with what there? G. Why? Because the body is moving what there? Vertically downward, which is this way, vertically downward. Now with this said, so force, the force here becomes mass times gravity, or M times G. Again, because we're dealing with density and liquid here, want to recall that density, so density, which is rho, is equal to mass all over volume. Of course, density is mass per unit volume. From here, if I cross multiply, mass times 1 gives you mass, equal to density times volume gives you density volume. So that means mass can still be expressed as the product of density and volume. If I bring this into this equation here, you have that U, upthrust, is equal to, in place of mass, I'll put density times volume, and then we have what there? Gravity. So we can calculate upthrust by multiplying density with volume and then with gravity. Okay, so with this said, let's use this formula to solve this question, right? Upthrust equal to density, volume times gravity. So from here, we'll have that upthrust U, it's equal to the density. Density of the body is given by 1000, 10 to the power 3. So density 10 to the power 3 times volume. The volume is 60 cm cube. Now, the thing here is that the volume here is in cm cube. Okay, so we have to do conversion. Volume is equal to 50 cm cube. All right. This is cm cube. This is kilogram per meter cube. This is G in meter per second squared. So let's convert this volume here from cm cube to meter cube. How do we convert this? There's a shortcut. I could just give you a formula for this, but let me teach you how you do conversion. Now, here's how to do proper conversion. If I'm to convert from cm cube to meter cube, what do I do? Here's what you want to note. Recall that we said 100 centimeters from basic conversion. 100 centimeters make what there? 1 meters. We have this, all right? If I want to get cm cube, all I have to do is cube this part here and also cube this part here. This becomes 100 cube. So 100 cube. This cube also affects the cm here. It becomes cm cube is equal to, this cube affects 1. It becomes 1 cube. And then this cube affects meter. It becomes meter cube. Proceeding with this, I would have 100 raised to the power 3. And if you do that, that gives you 1 million. So 100, this 1, 2, 3. You have 1 million. Yes. So 100 to the power 3 gives you 1 million. 1 million cm cube. So 1 million here. Cm cube is equal to 1 cube here is 1. Then you have this one here. You have meter cube. So basically, this is the relationship between centimeter cube and meter cube. You want to note this relationship here. All right. Note this relationship. That is the relationship between centimeter cube and meter cube. Now, after this, the next thing you want to do here is that we are asked to convert from cm cube. So how do we do that? We know that 1 million, 1, 1, 2, 3, 1, 2, 3. 1 million centimeter cube is equal to 1 meter cube. We want to convert 50 in centimeter cube. Let's get the answer in x. We don't know the value. Let's call it x in meter cube. All I have to do here is cross multiply. 1 million times x gives you 1 million. 1 million x is equal to 50 times 1 gives you 50. To get the value of x, I'll divide here and also divide here too by 1 million. So 1, 1, 2, 3, 1, 2, 3. This one here, 1, 2, 3, 1, 2, 3. This cancels this. So x it's equal to 50 divided by 1 million. If you do that, your answer there is 0.0000005. You have this. All right, so this is your answer. Of course, this x, the value here was in meter cube, as you can see at this point here. So it becomes this in meter cube. In essence, to convert from cm cube to meter cube, you divide by 1 million. That's the concept, all right? I've just showed you how or why it's so. To divide this by 1 million, you have 0.12345 meter cube, all right? You can also Google this. This is the correct answer. So I was trying to show you how they get this, just in case you have to do your own conversion. In essence, the uptross U is equal to density 10 to the power 3 times volume 0.12345, then times gravity. Gravity is 10, so you have this. All right, so uptross U, it's equal to, I'll get my calculator, I'll punch 10 to the power 3 multiplying 0.12345, okay, then times 10. So the answer here is 0.5. If you do that, you have 0.5 as your answer. Uptross, as you said, is a force, so it will be in Newton. So you have 0.5 Newton. That's the value of this. So if you look at that, that is option C, 0.5 Newton. That's your correct answer. All right, so that one done. Let's look at question number 42. 42 says, from the diagram above, calculate the energy stored in the capacitor, right? Let's get energy stored in capacitor. All right, so how do you solve that? We'll take this one off. Now you want to note that energy stored in the capacitor 42 is given by E, and that's equal to half times charge times V, all right? That's voltage. Half times charge times voltage. Looking at the question there is no value for charge there. You're given 8 microfarad, and that is the value for capacitor or capacitance. C is equal to 8 microfarad. I know this is capacitance from the unit because it is capacitance that is measured in what there? Farad. Meanwhile, charge Q is measured in coulomb. All right, so since coulomb, that's C. All right, so since we don't have coulomb here, that's not charge. So is there a way we can bring in capacitance here? Yes, but we know that charge Q is equal to what there? CV. This formula exists. If I substitute this value of Q here with CV, I'll have that E is equal to half 1 over 2 times Q. The value of Q is CV, and then we have what there? V. So this is Q and then V. Multiplying this, I have half into C. V times V is V squared. All right. So E is equal to half C V squared. Let me take this part off. Okay. And that's equal to half into C. What's the value of C? C is 8 microfarad. Now, when we say micro, that becomes 8. Micro is 10 to the power minus 6. That's coulomb. That's the charge in micro. So when we say 8 micro, simply 8 times 10 to the power minus 6. And then you have V. V is 10. So times 10 volts. So this times 10. V is squared here. So you can see it's squared. So I'm just going to square this. Square. And that's equal to, we punch this, you have your answer as, let's see, 0.5. That's half times 10 to the power minus 6 times 10 squared. You have your answer here as 0.0004. We're calculating the energy, right? Yep, energy. So that's in joules. So this is in joules. Let's convert this to index form. This is equal to, from here, if I move 1, 2, 3, and 4. I need to move 4 times. So it becomes 4 times 10 to power minus 4. Since I have to move 4 times, then joules. So let's see if we have this option there. 4 times 10 to the power minus 4. Yes, we do. That is option B, this one here. So next up, question 43. 43 says a spring of force constant 1500 Newton per meter is acted by a curved force of 75 Newton. Calculate the potential energy stored in the spring. All right, let's get this. So for 43, you want to note that the formula to calculate potential energy, PE, is simply equal to half times F, force, times E, extension. This is the formula to calculate the potential energy on a spring. Now, let's look at what we are given. We are given force constant 1500 Newton per meter. So K is equal to 1500 Newton per meter. Okay, they said by a curved force of 75 Newton. So F is equal to 75 Newton. You have this. Right, so how do we get it? Because for us to get potential energy, we need the value of F and E. We already have a value for F, but not E, not for extension. So how do we get the extension? We recall that from Hooke's law, F is equal to KE. To get the value of E, extension, divide here by K, divide here by K, this cancels this. So the extension E is equal to F all over K. Let's impute values. This is equal to F is 75 all over K is 1500. If we do this, 75 over 1500, that's about 0.05. So I have this as 0.05. Extension is in meters. So from here, we can now get the value of potential energy, PE, as equal to half 1 over 2 times F. F is 75. That's the force. Times extension. E is 0.05. Let's multiply this. What do you have? Half times 75 times 0.05. You have your answer as 1.875, which is approximately 1.9. We are calculating energy. Energy is in joules. So you have the answer as 1.9 joules approximately. Let's see which option that is. That is option A, 1.9 joules approximately. So you have this. Question 44. A constant force of 5 Newton acts for 5 seconds on a mass of 5 kilogram initially at rest. Calculate the final momentum. So option A there, 125 kilogram meter per second. Option B, 25 kilogram meter per second. Option C, 15 kilogram meter per second. Option D, 0 kilogram meter per second. How do we solve this question? Now, in solving this question here, question number 44, the formula we use here is to recall that impulse is equal to momentum. All right, we've discussed impulse in our previous class. So check out our full JAMB playlist. All right, so you can see our class on impulse and momentum. Now, we said impulse is equal to momentum, typically because they have the same SI units. And we know that impulse is simply force times time. That's impulse, right? Force times time. That's impulse is equal to, well, not just momentum, but a change in momentum. So change in momentum. So force times time, which is impulse, is equal to change in momentum. That's P. We use P for momentum. Again, you want to record that, but momentum P is equal to product of mass and velocity. So force times time for impulse is equal to change in mass times velocity. All right, change in mass times velocity. And if we put this in proper context, we'll have that impulse, force times time, is equal to mass. Change in velocity is simply final velocity minus initial velocity. That's U. So we have this. So multiplying this through, this would be equal to mass times final velocity minus mass times initial velocity. We have this. All right, so from here, we have force times time being equal to mass times final velocity minus mass times initial velocity. Looking at the question that they said initially at rest. When a body is initially at rest, it means that U is equal to 0. And if U is 0, we'll have force times time is equal to mv minus m. Initially at rest, U is 0. That becomes m times 0. That gives you 0. So it cancels out this equation. In essence, we'll have that force times time is equal to mass times final velocity. What you have here is the expression for final momentum. Right? So final momentum is simply mass times final velocity. We are asked to find this value. In essence, this value is simply equal to, that's final momentum is simply equal to force times time. What's the value of force? What's time? Looking at this, force is 5 Newton, right? The force there is 5 Newton, the time is 5 seconds. So if you multiply this, this is equal to force 5 Newton times time 5 seconds, and that's equal to what there? 25. And that's equal to 25 kilogram meter per second. So we have this. All right, so that's the value. Observe that we were not asked to find final velocity. If not, we would have divided this by mass. So 25 kilogram meter per second. The correct option there is B. All right, question 45 says, which of the following representation is correct for an atom X with 28 electrons and 30 neutrons? Now, how do we solve this? They give you number of electrons E as equal to 28 electrons, number of neutrons N as equal to 30. Right, you have this 30, this, and they said the element is X. Right, there's something called a nuclide symbol. A nuclide symbol of an element X is the symbol of that element showing its atomic number. So I'll put here as atomic number will be here, and then the mass number will be this one here, mass number. You want to know that atomic number is equal to number of protons. So let me call this AN. Atomic number is equal to number of protons. But in the case where you have an element that is neutral, now a neutral element or a neutral atom is an atom that does not have any charge. They gave you X, it was not plus 2 or minus 2. No, it was just X. Now the fact that this is just X without plus or minus means it's a neutral atom. And for a neutral atom, number of protons P is equal to number of electrons. And number of electrons is equal to, from the question, they give you 28. So that becomes 28 there. In essence, atomic number AN is 28. So here is 28 here. Then when it comes to mass number, let's call this Mn or atomic mass. Mass number or atomic mass is equal to proton plus neutron. And that's equal to the proton, as we've just said, is 28 plus the neutron. How many neutrons do you have there? 30. So plus 30. And if I add this up there, 28 plus 30, I have 58. So I have 58 as my mass number. This becomes 58. So my answer there is 58 up to the 8 down X. So that's option A. So that's the correct answer. Next up, 46. Which of the following 46, which is the incorrect formula for a body accelerating uniformly? Right, which of them is incorrect formula? A, V squared minus U squared over 2. That's not correct. B, V equal to U plus AS. That's not correct. C, S equal to half UT plus 80 squared. No, that should have been S equal to UT plus half 80 squared. So that's incorrect. D, V minus U equal to 2AS. That's also not correct. So here, basically, there's no correct option. Right? We're asking for incorrect formula. Literally, everything here is incorrect if you know the equations of motion. So, no answer here. No answer. All right, so you want to take notes. Perhaps it could be from the guys that typed this. Maybe they typed it wrongly. It could be, but looking at what we have here, there's no correct option. Okay. 47. Determine the focal length of a thin converging lens if the power is 5 diopter, right? Focal length of a thin converging lens if the power is 5 diopter. So how do we solve this question here? Now to solve 47, you want to note that power of a lens P is equal to the inverse of the focal length, right? That's how you solve this. And these two can switch position. That means focal length goes up, focal length F is equal to 1 all over power of length. In essence, the focal length is equal to 1 all over, the value of the power of the length here is, let's say, 5 diopter. So P is 5 as we're given. So 1 all over P, which is 5. All right, so I'll get my calculator and punch 1 over 5. You have your answer as 0.2. Focal length is in meters, F. So the answer is 0.2 meters. Looking at the option there, you have B, 0.2 meters. So that's your answer. Next up, question 48. Which of the following cannot be used to measure the temperature of a substance? A. Variation of pressure with temperature. B. Expansivity of liquid. C. Change in resistance of a conductor. D. Change in color with temperature. So how do we answer this question? Option A there, variation of pressure with temperature is the property used by gas thermometers. So it's used by gas thermometers to measure temperature. So that can be the answer. B, talking about expansivity of liquid. Note that expansivity of liquid is used by bimetallic thermometers, and hence that's what they use to measure temperature. So that cannot be the answer. C, when we talk about change in resistance, you want to note that the change in resistance of substance is used by something called a resistance thermometer. In essence, option A here is used by gas thermometer to measure temperature. Option B here is used by bimetallic thermometers to measure temperature, while option C here is used by resistance thermometer. So the answer is D, change in color with temperature. That's your answer. All right, question 49 says calculate the angle of minimum deviation of a 60-degree prism of a refractive index. Take the sine inverse of 0.75 as 49 degrees. So how do we solve this question here? Now, you want to know that you're given a refractive index of a prism, which is obviously a triangular prism. So how do we solve this? Now for 49, you want to recall the formula for refractive index. Now for a triangular prism, N, refractive index N is equal to sine of half A plus D all over sine half of A. Sine half of A. So what we have here is the formula for calculating refractive index. Now, when they say minimum deviation of a 60-degree prism, what you have here, this value, 60-degree prism, is called the angle of prism, and that's simply A. So you're being given the value of A here as simply 60 degrees. So if you put that value here, we'll have that N is equal to sine half into A is 60 plus D all over sine half of A. A is 60. Let's proceed with this. This is equal to, I'm having this as sine into half of 60 plus D all over sine half of 60 is what there? 30. So I have this as sine 30. Again, you want to note that the value of n here is a constant, right? And for prism, the value of n is equal to 1.5. It's a constant. So what do you have there? N, which is 1.5, is equal to sine 1 over 2 into 60 plus d all over sine of 30. Now in solving this is of course all over 1. So it becomes this times 1. Sine of half into 60 plus d times 1 gives you sine of half into 60 plus d. This one here, it's equal to This multiplies this. That gives you 1.5 sine 30. So we have this. All right. Proceeding from this, this becomes sine half 1 over 2 into 60 plus d. It's equal to, I'll punch 1.5 sine of 30. All right. That becomes half of 1.5, 0.75, 0.75. So I have this. All right. Proceeding from here, of course, to solve this, next thing I have to do is take sine inverse. If I take sine inverse here, it cancels this sign. So I have 1 over 2 into 60 plus d is equal to sine inverse, all right, sine inverse of what I have here, 0.75. So that's how to eliminate sine from this part, right? Take sine inverse of both sides to cancel out this sign. Okay, I think they give us a value for sine inverse of 0.75. Let's check again. Take sine inverse of 0.75 here as 49. All right, so this is 49. So we are saying that half 1 over 2 into 60 plus d is equal to what there? 49. So we have this. So how do we solve this? Now, in solving this, of course, 1 times 60 plus d gives you 60 plus d all over your denominator here, 2. This is equal to what there? 49. Of course, this is over 1. Let's proceed with this. Let's proceed with this. This is equal to 1 times 60 plus d gives you 60 plus d is equal to 2 times 49. That becomes 49 times 2, which is what there? 98. To get d, I'll move 60 over to this point here. Becomes 98. 60 becomes minus 60. So 98 minus 60 gives you 38. So that's the value of d. So d there is 38. And your answer should be in degrees, of course. That's the angle of deviation, 38 degrees. All right, let's see what option there. Option A, 38 degrees. You also want to note that this is a constant, just in case. All right, the value of d is usually 38 or something close to 38, 37.5 also. Final question here. Question 50 says, what is the cost of running 740 watt lamps and 580 watt lamps for 12 hours if the electrical energy costs 7 naira per kilowatt hour? That should be this, 7 naira per kilowatt hour. A, 80 Newton, B, 45.36 Newton, C, 65 Newton, D, 57 Newton. So how do you solve this question here? Now, to solve this, the first thing we want to do here is to get the total power. So question 50, let's get total power, right? Total power in watts, and that'll be equal to the number of lamps. They said 740 watt lamps. So it becomes 7 times 40. So it becomes 7 times 40 plus, okay, let me close this first. This plus the other one that we have what there? 580 watts. So it becomes 5 times the number of, so you have 80 watts, 5 of it. So total power here will be equal to, I'll just punch this directly and see what I have. So open a bracket, 7 times 40, close the bracket, plus, open a new bracket, 5 times 80. If I do that, my sum gives me 680. This is in watts. Now, looking at the question that they said, the cost is 7 naira per kilowatt hour. So we want to get kilowatts. So let's convert this to kilowatts. So the total power is equal to, in kilowatts, let me call this in kW. In kilowatts is simply 680 divided by 1000. All right, and that gives you 0.68 kilowatts. So the total power is equal to 0.68 in kilowatts. All right. Now they said, how long did you operate this? They say you operated this, or the operation of this particular electrical appliances was for 12 hours. So once you get the total time there, in essence, that will be equal to the total power 0.68 times how long it has been in use, which is 12 hours. Now, I'm not converting hours to second because this is in kilowatt hour. So kilowatt hour means multiply the power, kilowatts, times the time, hour. So it becomes times, the time then hour is 12. So we have this. And that's equal to 0.68 times 12. And that's 8.16 kilowatts hour when you multiply this. So when you multiply this, you have this. Now, if the electrical cost or the electrical energy cost is 7 naira per kilowatt hour, that means if you have 8.16 kilowatt hour, how much would you pay? You simply multiply this value by this amount here. So it becomes 8.16 multiplied by 7, since you charge 7 naira per kilowatt hour. So I have 8.16 times 7. That gives you 57.12. Of course, the charge is in naira, so you have this 57.12. So coming back to this, you can see that the correct answer there is D, 57.12 naira. Okay, so the correct answer there is D, 57.12 naira. All right, so this is how you answer this question. So with this, we are done with JAMB Physics 2022 questions. So in our next set of classes, we also provide the JAMB solution for physics, chemistry, mathematics, and biology between the year 2015 to 2025. So make sure you check daily for new classes. All right. Okay, guys. So please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.journalemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comment, I gave you a task, question number 11. Solve it. Leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.